This video gives the idea about structure for realization of FIR system. Okay, so there are three types of structures for realizing FIR system. They are direct form realization, cascade realization, and linear phase realization. So let us see direct form realization first. We know the difference equation governing this FIR system is this. That is, y of n is equal to sigma m is equal to 0 to n minus 1 bm x of n minus m. That is, output of FIR system depends on the present input and the past inputs only, not the outputs, as in the IIR system. Okay. അപ്പോൾ ഇവിടെ ഇതാണ് equation expand ചെയ്ത് എഴുതി. അതിന് we have to take the Z transform both sides. Okay. So we'll get y of z b0 x of z b1 z raised to minus 1 x of z like that. Okay. So b n minus 1 z raised to minus n minus 1 x of z. Okay. So this n represents the order of the filter. This capital N represents the order of the filter. Okay. In the direct form structure, you can see it's directly, you can represent that equation. That's only. So in the left hand side, you have x of z. At the right hand side, you have y of z output. So y of z is equal to, first one is b0 x of z. That is, I multiply x of z with b0. That is, b0 x of z will be added with, then we need z inverse x of z. For that, we need a delay unit z inverse x of z. So after going through this z inverse, this x of z become z inverse x of z, and that is multiplied with b1. Okay, b1 and added with this b0 x of z. Then, so this is b1 z raised to minus 1 x of z will be added with this. Again, next is b z raised to minus 2 x of z into b2. So take here we get z raised to minus 1 x of z. So after placing one more delay unit, you will get z raised to minus 2 x of z. Okay, this 2z delay unit gives z raised to minus 2. Then you have to multiply it with b2 and add it. Like that, you have to add, and finally the last one, that is z inverse. So you should have n minus 1 number of z inverse delay unit here. So this delay unit should give b of n minus 1 z. Finally, all will be added together to give the y of z. Okay. So here realization of nth order filter involves n number of multipliers. N number of multipliers are required, and n minus 1 number of adders, and n minus 1 number of delay units. Okay. So it requires n minus 1 memory locations. So that is the all the things about direct form realization. Okay. The next is cascade realization. So in cascade realization, what we have is, we have our h of z, that is y of z by x of z, which will give only numerator only, not okay. In FIR system, we will have only numerator, not the denominator. So this polynomial, so here this h of z in cascade form, what were series connected h of z, smaller transfer functions. Okay, series connected smaller transfer functions. That is product of smaller first and second order transfer functions. So here we have to factorize this equation into second and first order factors. Okay, this polynomial can be factorized into first order and second order factors, and this can be implemented using direct form like this. Here it is shown in vertically. It is here it is shown horizontally. Here it is vertically. So each fraction you have to implement using direct form structure and cascade it. That's all. Okay. Finally, you will get input here. Finally, the final output will be. So that is the cascade structure. So next one is the linear phase realization of FIR filter. Okay, linear phase realization of FIR filter, in which it is a you will get another question like this. You have to realize the FIR system with minimum number of multipliers. That also linear phase realization. Okay, minimum number of multipliers വെച്ചിട്ട് realize ചെയ്യാൻ പറഞ്ഞു കഴിഞ്ഞാലും അത് linear phase realization ആണ്. Okay, okay. Linear phase എന്ന് പറഞ്ഞാൽ എന്താണ്? FIR സിസ്റ്റത്തിന്റെ linear phase എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ h of n is equal to h of minus n ആണ്. Here നെഗറ്റീവ് പാർട്ട് ഇല്ല, പോസിറ്റീവ് പാർട്ട് മാത്രമാണ് നമ്മൾ 0 to ആണ് കൺസിഡർ ചെയ്യുന്നത്. സോ വി ക്യാൻ റൈറ്റ് ഇറ്റ് ആസ് h of n is equal to h of n minus 1 minus n, where capital N is the order of the system. Okay, and there will be two conditions for n is equal to even and n is equal to odd. Okay, when n is equal to even, you will get a structure like this, and when n is equal to odd, you'll get a structure like this. I can explain it using an example. That will be better. This is a question you will get. H of z is equal to 1 by 4 plus 1 by 2 z inverse plus 3 by 4 z raised to minus 2 plus 1 by 2 z raised to minus 3 plus 1 by 4 z raised to minus 4. Here n is equal to, what is the maximum power is here? That is minus 4. That is minus n minus 1. N minus 1 is 4. So n is equal to 5. So it is odd value of n. Okay. So here in this equation n is equal to 5. So here what we get is n minus 1. Okay, n minus 1 is 4. So n is equal to 5. And y of z. And here before implement it, you have to check whether it is linear phase or not. Linear phase ആണോ അല്ലയോ എന്നുള്ളത് നോക്കണം. Linear phase ആണെങ്കിൽ എന്താ പറഞ്ഞിരിക്കുന്നത്? h of n is equal to h of n minus 1 minus n. Here n is equal to 5. 5 minus 1, 4. 4 minus n ആണോ നോക്കുക. അതായത് h of 0 is equal to h of 4 minus 0. അപ്പോൾ h of 0യും h of 4ഉം ഈക്വൽ ആയിരിക്കണം. So this is h of 0, 1 by 4. This is h of 4. That also 1 by 4 equal. Okay. Then h of 1 and h of 4 minus 1, h of 3. h of 1 and h of 3 are equal. Okay. And this will be a centered term that will be as it is. And next is what we have to do is what is h of z? Y of z by x of z. You have to write like that and cross multiply with x of z. Multiply with x of z all these terms. Okay, y of z by x of z, then cross multiply. We'll get the equation like this. Then after that, what you have to take is you have to take the common coefficient separate. That is 1 by 4. If you take 1 by 4 outside, you will get x of z and z raised to minus 4 x of z. Like 1 by 2, if you take 1 by 2 common, you will get z raised to minus 1 x of z and z raised to minus 3 x of z. Then 3 by 4 z raised to minus 2 x of z is separate. Okay. Now we can implement it using the structure. For that, how many delay element do you require here? 4. Okay. Z raised to minus 1, z1, 2, 3, 4. You have to first you have to draw all the 4. How many you required? You have to draw like this in symmetric. Like 2 up, രണ്ടെണ്ണം മുകളിലും രണ്ടെണ്ണം താഴെയായിട്ടും z ഇൻവേഴ്സ് വരയ്ക്കാം. ഓക്കെ, അപ്പൊ എക്സ് ഓഫ് ഇസഡ് ഈ z ഇൻവേഴ്സിലൂടെ കടന്നു പോകുമ്പോൾ എന്താ കിട്ടുക? z ഇൻവേഴ്സ് എക്സ് ഓഫ് ഇസഡ്. വീണ്ടും അത് ഇതിലൂടെ കണ്ടുപിടുത്തു പോകുമ്പോൾ z റേസ് ടു മൈനസ് 2 എക്സ് ഓഫ് ഇസഡ്. പിന്നെ അത് ഇതിലേ വന്നു, ഇവിടെ എത്തിയപ്പം വീണ്ടും ഒരു ഡിലേ യൂണിറ്റ് z റേസ് ടു മൈനസ് 3 എക്സ് ഓഫ് ഇസഡ്. പിന്നെയും ഇത് ഒരു യൂണിറ്റും കൂടെ കടന്നു പോകുമ്പോൾ z റേസ് ടു മൈനസ് 4 എക്സ് ഓഫ് ഇസഡ്. ഓക്കെ, ഇത്രയും ഫസ്റ്റ് വരയ്ക്കുക. ഇതാണ് ഫസ്റ്റ് വരയ്ക്കേണ്ട സ്ട്രക്ചർ. അതിനുശേഷം നോക്കുക, 1 by 4 മൾട്ടിപ്ലൈ ചെയ്യേണ്ടത് എവിടെയൊക്കെയാണ്? എക്സ് ഓഫ് ഇസഡിലും z റേസ് ടു മൈനസ് 4 എക്സ് ഓഫ് ഇസഡിലുമാണ്. ഓക്കെ, so add x of z and z raised to minus 4 x of z. x of z plus z raised to minus 4x of z, which will be multiplied with 1 by 4. Okay, that will be added with another number. അടുത്തത് z raised to minus 1x of z and z raised to minus 3x of z should be added together. z raised to minus 1 x of z ഇത് ഇവിടെ z raised to minus 3x of z രണ്ടും കൂടെ എടുത്തിട്ട് ഒരു ആഡറിൽ കൊടുത്തിട്ട് ആ ആഡറിൽ നിന്നുള്ള ഔട്ട്പുട്ട് എടുത്തിട്ട് you have to multiply with 1 by 2. That will be added with this. And finally 3 by 4 should be multiplied with z raised to minus 2x of z. Z raised to minus 2x of z is here. Have to multiply 3 by 4 with this and add with this. So all together added, you will get y of z. So I have implemented the equation. Okay, let us see another example also. Here, h of z is equal to 1 by 3, 1 by 4 z inverse, 3 by 2 z raised to minus 2, 3 by 2 z raised to minus 3, 1 by 4 z raised to minus 4, 1 by 3 z raised to minus 5. Okay, here maximum term is 5 minus 5, so n is equal to 6. Okay, here is comes n minus 1, so n is equal to n minus 1 is 5, so n is equal to 6, so it is an even number. Now let us see what is the difference. Okay, in this, so we have to write equation as such, that is h of z is equal to y of z by x of z, then x of z will be cross multiplying it with all the terms, so you'll get x of z like this, and you have to check whether it is linear phase, that is 1 by 3, 1 by 3, 1 by 4, 1 by 4, 3 by 2, 3 by 2. Okay, that is h of 0 is equal to h of 5, h of 1 is equal to h of 4, h of 2 is equal to h of 3. Okay, if you get like this, it is in linear phase, and you can implement it using this equation. So here also you take the common coefficient separate, then you will get x 1 by 3. If you take 1 by 3 common, then x of z and z raised to minus 5 x of z. 1 by, if you take 1 by 4 common, z raised to minus 5, like that. Okay, so before writing you have to before drawing the structure you have to check how many delay unit you require here. Okay, so here 5 delay units. 5 delay unit, when you draw the 5 delay unit, you have to draw 2 upper, 2 lower, രണ്ടെണ്ണം മേളിൽ വരയ്ക്കുക, രണ്ടെണ്ണം താഴെ വരയ്ക്കുക, ഒന്ന് ഇവിടെ സെൻട്രലിൽ വരയ്ക്കുക. ഓക്കെ ഓക്കെ 5 നമ്പർ ഒക്കെ ഉണ്ടെങ്കിൽ ഇങ്ങനെ വരയ്ക്കണം. ഓക്കെ, ഈക്വൽ നമ്പേഴ്സ് ആണെങ്കിൽ ഇപ്പം 6 ആണെങ്കിൽ എന്താ വേണ്ടത്, 3 മേളിൽ 3 താഴെ വരും. ഇതിപ്പോൾ 5 ആയത് കാരണം സിമെട്രിക് ആക്കാൻ വേണ്ടി 2 2 2 2 ഇങ്ങനെയാണ് വരയ്ക്കേണ്ടത്. ആഫ്റ്റർ ദാറ്റ് x of z will be multiplied with added with z raised to minus 5 x of z. Okay, ഇത് എത്ര എണ്ണം ഉണ്ട്, 5 എണ്ണം ഉണ്ട്. അപ്പം 5 എണ്ണത്തിലൂടെ കടന്നു വരുമ്പോൾ ഫൈനലി വിൽ ഗെറ്റ് z raised to minus 5 x of z. ഓക്കെ, അപ്പം x of z ഉം z raised to minus 5 x of z ഉം കൂടെ ആഡ് ചെയ്ത് ഹാവ് ടു മൾട്ടിപ്ലൈ വിത്ത് 1 by 3. ഹിയർ ഇതുപോലെ നോക്കാം, z raised to minus 1 x of z ഉം z raised to minus 4 x of z ഉം കൂടെ add either, have to multiply with 1 by 4 and added with this, like that. Z raised to minus 2 x of z z raised to minus 3 x of z കൂടെ വന്നിട്ട് 3 by 2 ആയിട്ട് multiply ചെയ്ത് we get finally y of z. Okay, so this is the FIR realization structure. 3 structures: direct form, cascade form, and linear phase. Linear phase is you will get question linear phase, like you have to implement it using minimum number of multipliers. So here minimum number of multipliers, we have used only 3 multipliers here. Okay, so since there are 6 coefficients, we have used only 3 multipliers by implementing like this. So here we are using minimum number of multipliers. Okay, thank you.